Right, morning gentlemen.
Morning.
Nice to see you all. My name's David. The company is Red Dragon Laser. We're based in Wales, but as you've probably guessed already, I'm not Welsh. I'm actually a Worcestershire lad. I'm a great fan of Scotland. I'm not saying that, but my ex-wife, my late wife, would murder me if I didn't say that. She was Scottish. We used to have a house just up north of Inverness, and I did my mountain leader training at Loch Goyle Head. I've done 212 of the Munros, so I've still got a half a dozen or so to do. But I'm afraid that as the years creep on, my chances of getting up some of them are getting more remote. But
it's a nice day today.
It's a beautiful day today. Yeah. This is the sort of weather I love going up, because it kept the casual wanderers away from the scene, so you got more of the hill to yourself. Anyway, right, before we start, just while we're doing this, before I go through the machine itself, I just want to do the safety part. I'm leaving a copy of this for you so you can pin this up somewhere. And the basic idea of doing the safety part is to scare you to death. It is a laser machine. It's like a bandsaw, it's like a circular saw, it's like anything else. If you misuse it and abuse it, it will cut your fingers off. If you treat it properly, it will be absolutely fine and it will produce the items that you want it to produce. So, in order to assess the potential dangers that laser systems pose, they're put into 4 separate categories, 1 to 4, 1 being the most benign, 4 being the most dangerous. We took a decision early on when we were doing this that technically this is a class 1 / class 2 laser. We classify it as a class 4, the most dangerous part. The reason being is that we do not want anybody lulled into a false sense of security. The laser beam itself going round inside there, you cannot see. You put your hand into the laser beam, it will scar and mark you. The only decent thing is, at least it cauterises the wound when you go round, so you won't drip a load of blood everywhere. But we did this as a scare you is the wrong word, to make you realise it's a machine to be treated with respect. Just because you can't see a whirling blade, it doesn't mean that it doesn't have the potential. So we put here that it's a class 4 item. The biggest danger with these is fire, because you're applying heat to combustible material. And just follow normal safety precautions and that's not an issue. Okay, if you're going to operate the machine with the lid open, which for certain things that you can do, you need to wear correct eye protection. The next thing is make sure that you don't open any part of the machine, including the main lid, when the laser's in operation. So you've got various side panels. These have got proximity switches here. The rear panel here has got a proximity switch over the top of the laser tube. If you lift any of those up, it'll stop the operation of the machine. A CO2 fire extinguisher should be placed somewhere in the vicinity of the machine, so that if you do have a problem, you can cope with it before it gets out of hand. Do not store any flammable materials inside the machine. I've gone to people and they've, especially the large machines which have got doors on the front, and they've put cardboard and plywood into that nice little storage area where the bits and pieces are supposed to drop down to. No. Always maintain a free airflow around the machine. So we don't put it into a cupboard, we don't put it into enclosed space. We keep the air circulating around it. Ensure that the machine is placed on a secure, level surface below shoulder height. Do not disable any of the safety switches. By disabling the safety switches, don't go around putting
Oh, don't show us how.
things like that on there, which will disable that. It's because the first couple of cuts and engraves that we do, we're going to do with the lid open so we can actually see what's happening. The main one is do not leave the machine unattended when it's in operation. Don't just start it off and go away. In our history, we've been going for just under 5 years now. In our history, we've had 2 machine fires. One, the guy doesn't know how it happened because he was off in the kitchen cooking dinner at the time while the machine was going away. The second one was at a school in South Wales where the teachers went off, left the kids. The kids started off the programme, went off and away into the playground, and the next the teachers know they're having a nice cup of tea, and the kids came in and said, Sir, the classroom's on fire. So, yeah, we had the fire brigade and everything in there. We had to rush them out to another machine so they could complete their end of year exam. It's your responsibility as a group to verify that the materials you're using are safe to be used. Now, some of the materials that you use, especially some of the plastics, can give off gases. The common ones for these are PVC, polyurethane, polystyrene. I'm allergic to anything that begins with poly. What you do with those is that you can get chlorine gas to come off. Now, the extraction system that we've got will cope with the majority of that, but just be careful and don't use them. Don't do them. If you want to cut polystyrene or polyurethane or something like that, don't use a saw. Don't use a laser. Okay, that's the sort of safety.
Can I just ask, does that stop you using PCBs? Etching PCBs a bit?
No, PCBs generally are okay, but just do a quick Google search and see that the PCB printed circuit board that you're trying to etch, and just do a, just make sure on that. Apart from that, if it's just a small amount, which is what you're going to do with the PCB, then you've got no problems. But if you've got 2-inch thick polystyrene that you're trying to cut, and you'll get a thick toxic smoke coming off it, if basically it makes you cough, be very wary.
What about standard plywood? It's just going to be in queue and getting a 6x4 sheet of plywood.
Yeah, fine, no problem. You'll find laser ply and laser suitable plywood on the market, and you'll find the standard plywoods on the market. You'll find this with MDF as well. And with both of these, it's not the wood, because the wood part of it is the same on both. It's a bonding material that they use. And the laser plies, then they tend to use a water-based adhesive, whereas on the commercial ply for cheapness, then they use a resin-based adhesive. Especially on sort of chipboard and that sort of thing, you tend to get a very sooty finish because the resin itself burns, and you just get a bit of a sooty finish. Also, with some of the cheaper plies, they use recycled wood in the central parts. When they veneer the wood in the centre, it can have screws, it can have bits of metal. I remember a friend of mine, a timber merchant, he bought a load of ply in, he said, really cheap. He said, but the trouble is, I can pick it up with a magnet. There's so much metal in there. But it's true, if you have a look at ply, then you'll find that if you cut it with a bandsaw or a circular saw, you'll get sparks coming off it, which is just where you're hitting, there's been a screw or a nail when they've veneered it. You get a nice finish on the outside, you get absolute rubbish in the middle. And that's the way that they're making the plier. So material's going to be used. This laser will work on any non-metallic. It won't work at all on metal. If you've got an anodized metal, so it's got a nice coating on, the laser will take the coating off and reveal the metal underneath. So you can do signs, you get the black anodized aluminium. That's great. It'll take the black off, reveal the lettering from underneath, and you can do anything from hip flaps to signs and that sort of thing. But it won't cut steel, brass, any sort of metal at all. What it will cut is anything that will burn. So any of the woods, any of the plastics, those will all cut quite nicely, as well as engrave. You can also engrave slate, stone, glass. It will cut and engrave leather. Just think of the range of materials that are out there. You can make rubber stamps. You get the rubber for those. It stinks to high heaven, but it's quite okay. Leather is awful. It smells like a barbecue that went totally wrong. But it will do all of those.
It could do glass, you say, yeah?
Yeah.
That's very hard, dyeing that material. Glass.
Yes. Warnings with glass. What it does with glass is that when you're engraving it, won't cut, but when you're engraving it, what it does is fracture the surface of the glass. What you don't want to do is to pick it up once you've engraved it and go, oh, that's all right. You end up with a small cloud of glass shards. What you don't want to do is wipe it off with your hand. What we always suggest is that you just get a light sponge and just wipe it off with that. If you're engraving...
So it won't cut glass.
Won't cut it?
It'll etch it.
No. If you're doing clear acrylic there, I always tend to take the backing of acrylic. It doesn't matter either way. But if you're doing lettering on there, you end up with the backing material, little bits of it stuck in the letters, so you've got to go around and pick it off. So I just find it easy to get it off in the first place. If you are engraving acrylic, then again, what it does is that it engraves by turning the surface into a fine powder. That powder, because of the way the laser works, then settles on other parts of it, and you can get a frosting effect going around the lettering or going around the shape, which some people like. Which, if you're doing Christmas scenes, little snowman frosting around it, looks great. If you just want to do nice clear lettering, just get some very cheap washing up liquid and just wipe it over with washing up liquid, put that in, engrave it, the dust then settles onto the washing up liquid, you can wipe it straight off. You get a really nice, good, clean finish on that. If you're engraving wood, you will get a little bit of smoke, and the easy way with that is either just to run a light sand over it, or to put masking tape onto it and engrave it through the masking tape, and then the smoke then lingers on the system there. We have got a very good Facebook page, if any of you are on Facebook, and you'll get a lot of tips, hints, tricks, suggestions, abuse on there. But yeah, so yeah, we can cope with 6mm acrylic on this quite easily. Okay.
What size
Is
of
it-
ply? 10.
Applying acrylic, you can cut probably about the same. Single pass, I'd probably say about 6 to 8mm. It's a 50-watt laser tube, so it is fairly punky.
One thing about glass, I suppose you're unlikely to get a bit of glass that's been toughened that will fit in there, but I'd imagine that if it was toughened glass, it might just sort of explode, disintegrate if you...
I wouldn't. I'll be honest. I've never tried it. I've never
Right.
tried toughened glass.
Yes.
But surprisingly, you put very little heat into these because the heat is concentrated in a tenth of a millimetre dot,
Yeah.
and that dissipates. Even when you cut these things, they come out and still, you know,
Yeah.
a normal
Just
room
the
temperature.
surface is in tension,
Yeah.
you know, compared to what's the
It-
core.
it-
Yeah.
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 Um,
I'm just asking.
Go
no,
for a
it's
toughened
not-
glass, put the
right,
lid
okay.
down and give it a shot. See
We'll
what it
try it out.
Okay, right. So this is the machine itself. Any questions so far? We okay as far as we've done? Okay. Right. This is the machine that we've got. So it's a working area of 400 millimetres by 400 millimetres. The laser tube runs. Pop this down.
You've got a screw in.
Well, do you mean our safety device 6? Okay, the laser tube runs the full width across here. The beam on the laser tube at this point is about 2 to 3 millimetres in diameter. The software that we've got over there controls the laser completely. It controls the amount of power, it controls the speed that the head will move at, and we use that to turn it on and off. So, laser beam comes along there. We've got a mirror just here inside, so the laser beam hits that and bounces off. The mirrors aren't glass, they're made out of molybdenum, one of the rare earth metals. If we use glass, obviously, then we'd engrave it. So we bounce off the mirror there. There is, in this side here, another mirror which goes backwards and forwards. That bounces the laser beam out to here, which then goes through a focusing lens at the bottom, and it comes out of the nozzle there, and at the correct focal distance it's a tenth of a millimetre in diameter. So we've actually done engraving text down to a millimetre high because we can get 10 lines in there, so it gives us enough space there to go and define text at a millimetre in height. It does mean that you can get very intricate designs and very detailed designs. Right, we've got our x-axis there, our y-axis there. When we turn the machine on, and the power switch for the machine is just tucked round at the back here, and it's a single green, that will turn on the air assist pipe, which comes down through here and gives us an air blow coming out of the nozzle. So that keeps the smoke away from our working area. It turns on our water pump, which feeds water round the laser tube at the back as a coolant. The laser tube itself is 3 tubes. You've got an outer tube, a middle tube and an inner tube. The inner tube is the one that actually carries the laser beam. The water goes between the middle tube and the inner one, and that just keeps the system cool. If the weather is getting hot, the operating range for the laser is anything above about 35 degrees. The laser will start to deteriorate. It's not a permanent deterioration, it will just deteriorate while it's warm. So you've got a water container down the bottom there. If you're unsure, just check the temperature of the water. If it feels warm, it is warm. The best thing to do is to get some cool blocks, the things that you get from Poundland or somewhere like that, and just put those in. Or get some bottles of water, freeze those up. We use deionized water because it's quite a thin tube way going down there. So don't put ice cubes in there and put northern water in, else we can get, you know, calcium build-up, limescale build-up. down
Not in
there.
Scotland.
Actually, this is very true. This is very true. But we've given you enough deionised water for 2 fill-ups. So, yeah.
Okay.
Funny enough, in Wales, it's dreadful. Actually, the water in Wales is dreadful. Right. So, that's our main external component. So we've got a pump in there that pumps the water around. If you move in this and you put it somewhere else, then the pump goes onto the inlet pipe. The outlet pipe comes round and just feeds back into the container. The reason it's got to be that way round is that we've got a flow device set up into the system, and this looks for a good water flow going past it. If the water flow isn't there, the laser tube won't work. If you put the pipes on the wrong way round, then it can't sense the water flow going round, so the laser tube won't work. Okay?
What about air bubbles in the tube?
They rarely give you any problems. The pump is only strong enough and it keeps the air bubbles going out.
You really don't want air bubbles.
You don't want air bubbles.
But in time, the other option is just to let it run for
Yeah.
5 or 10 minutes. If you see air bubbles,
That's it. It will just clear them out. Also, at the end of the day, just when you finish working, just give it 5 minutes at the end of the day just for the water to flow around, go around the system, and yeah, just even it all out so that we don't get any hot spots coming down. For a technical minded, there's a power supply in there which generates just over 20,000 volts. That goes into the laser tube, and that's what actually sparks up the laser to operate, the CO2 laser. Okay.
What is the machine used at? Is it 5 amps? 15?
5. Yeah, 5 amps, and turning it on turns everything else on. We have got an extractor fan built into the back, which we cunningly set up out of the top there. Yeah.
it wasn't me, it was them.
Okay. Right. Controller panel. This is your interface with the laser. Sorry, you've got a focusing lens within the nozzle head itself that brings this beam down from its 2 to 3 millimetre diameter to a 10th of a millimetre. In order to get that correct, I'll borrow this little bit of material here, then it's simple enough. That piece of material there, and you can cut some of these yourself, going in that direction, that's the correct focus length there. To adjust the focal length,
Right. I see.
then we have 2 buttons on the side there and a switch there. That turns on a motor, and that will then allow us to raise and lower the bed. Let's bring it up, bring it down.
What is that distance? You know, the
It's, they come with each individual, it's about 6 mil.
6 months. Aye.
But if you measure that up and then just use your software, and I'll show you how to make those. Okay. Right, so if you're going to be constantly using a very similar thickness material, there's no need to change it. I always do suggest that once you've got it right, then just turn that off. That'll stop that somebody leaning against that and changing the focus for you. Emergency stop switch at the top. If all else fails, give that a bang. That'll cut everything off. You've got an ammeter down here. The maximum working on the 50-watt tube is about 20 milliamps. So it's 20,000 volts for about 20 milliamps.
Just got a question about the focusing. Does it have the two-way red beams that focus as well?
No.
This is the alternative to that?
This is the alternative. We looked at the, you get the two red beam ones, and this is easier, simpler. If you lose one of the red beams, you've lost all your focus in it.
Right,
Yeah, so this is just an easier way of doing it. There are various systems on it. Okay, right, so that's that switch at the back. We've got two USB ports down here at the front. The top one is where your computer's plugged in. The bottom one, we can save designs, drawings to a memory stick and just plug those in without having to have a computer attached. But we'll stick to the straightforward today. Okay. Right. I think we can start having a play now. So if we use our bit of acrylic. Thank you. Okay, because that's a thicker material, then we'll need to drop the bed down just a little bit to cope with that. So that's it, simple. One thing, if the white light is not on, then there's no power to the laser tube. That's a safety device, so we have to turn that on. So when you're off and away, those keys can come out and then the machine is disabled. When that's on, it's difficult to see here, but there is a small red pointer light that gives you an indication of where it's going to start. Okay, let's just do a very simple, basic test first. Right, this is Lightburn software. The grid there is the same size as the grid that we've got that we're working on here. Now, there are
Is that standard, or do you set that grid?
sorry?
Is that a standard size, or do you have to set that grid?
When I set the software up in the first place, I tell it the working area of this. And actually, it goes off and interrogates the controller, and the controller tells it. So, yeah.
You say it's 400 and 400, right?
Yeah. Okay, yes. 400 by 400, you can cut all the way 400 by 400. You can't engrave 400 by 400. You've got a little area around there, because as the laser head is coming along and it gets to the end of the engraving part, it's got to slow down, so it turns off, starts to slow down, stop, turns around, comes back. So at both sides of your engraving, you've got a little overrun area, which is about 5 to 7 millimeters. So if you say that this is 400 by 400, your engraving area is back to front 400, that's okay, but it's a side where it's moving, is going to be probably about 380, 385 millimeters. Okay. Right. There are two main ways that you can use the software. You can put a 400 by 400 millimeter sheet of material into there, and exactly where you put your design on here is exactly where it will put it onto the machine. Now, the majority of the time I find that I'm using odd bits of material which aren't 400 by 400, and I don't want to have to measure everything out to make sure that I get it all in the right place. So I use a system called current position. So the first one is absolute coordinates. So if you've got it 97.5 millimeters in that way and 23.2 millimeters in that way, that's exactly where it's going to do it on there. If I just want to cut a circle in the top left-hand corner of this, or I want to do some work on this, then I find that I use current position. Down the bottom here, then we've got the start from, start from on this will be current position. And this just makes life so much easier. So, excuse me for having to keep coming in. So I go into there and select current position. I've then got a grid of 9 dots, and that's just where I'm going to start from. I can start from the top left, top right, bottom left, bottom right, or the centre. If I'm doing circular coasters, and if I'm engraving a circular slate coaster, it's easier to start from the middle. If I've got a piece of material like this, I tend to start up in the top left-hand corner. So if I just come over here and select the circle, and I do a circle there. That, if you can see, it has got a green indicator up in the top right-hand corner, and that's just telling me that it will do that circle to the left and down from wherever the laser started from. I can go down to my grid down here, which says job origin, and I can just flick that so it's then in the top right-hand corner. Now, all that means is that I can move my laser head to a convenient point. I can put my piece of material in, so my laser head is in the top left-hand corner there, and then I press my origin button there, and origin just says that's where I'm going to start from. Now it will cut that circle, start in there in that corner. That to me is a lot easier. If I've got a bigger piece of material, I'll move the head back over there, press origin, and then just move my piece of material over there that I want to cut. It's a funny concept, but it just is literally as easy as it does seem. That if you use the current position, you move the head to wherever you want to, so that whatever you're doing will fit on there, and you press origin. Origin just tells the laser, I've finished moving around, this is where I want you to start from. Right, that's all we have to do with the laser machine then. On here, we do our design, and our green indicator, our origin point, will always work from wherever we've told it to do up in the top left-hand corner. And we've got a design there that we can go down to. So I've got a circle there. If I just point at that circle, I just point at that circle. Up here, I've got width and height, and it'll tell me exactly how big that design is so far. At the moment, it's 63 millimeters by 57. I'm sorry, we're metric. I can either alter and drag and change that round there, or if I want that to be an exact 25mm circle, I can just put 25mm wide, 25mm high into the box, and it makes a circle exactly that size. I've got a little padlock symbol there. If that's closed, then it keeps the aspect ratio. So if I've got some text that I've done out there and I want it to be exactly 50mm wide to fit onto something, I lock that and then it'll make it 50mm wide and bring down the height of the course. Just go like that. And there we've got an exact 25mm circle. Okay, when we're actually using the laser machine, then we've got two basic things that we're looking at. One is the speed that the head's going to go at, and the second one is how much power we're going to put into it. Now,
It's all right.
okay, when you first get the machine, when you're first using this, you'll get some odd bits of material and you'll start having a practice and start building up your own library of speeds and powers. So you'll get some 6mm acrylic and have a look at this, and you'll get it just so that it'll just about cut that 25mm through. And then you've got 20 colours down here at the bottom. So for this, say, we could save this as black, and then all in future, all you've got to do if you want to cut 6mm acrylic in future is get your design and clip the cutting lines as black, and then that's already preset for you. You've got to do the presets in the first place, but once they're into the system, they're into the system.
But is that per individual person?
Yeah.
No,
Each set your own profile?
no, that's for the machine as a whole, because whoever it is that's cutting 26mm acrylic, it's the same setting.
As long as you keep a register of it, say that
Yeah.
4mm wide, and then it's cut and engraved.
Yeah.
And the depth you want to engrave.
Right. The other thing that you've got is that you've got two things. You've got cutting, and cutting generally that you'll move the laser head between about 5 or 6mm per second up to about 20mm per second, and you'll use the power at between 30 and 40% power, and that will be cutting. When you're engraving, you're moving the head a lot quicker because you only want to go a small way into the surface, so you'll probably end up doing engraving at somewhere between 200 and 350mm per second, and again at about 30–40% power. You want to limit your power on the machine to a maximum of about 65%. It's like driving a car, you don't go everywhere with your foot flat to the floor. To maintain the life of the tube and the length of the tube, then 65, 2/3 power as a maximum, if you use that as a rule of thumb. But again, using the analogy, if you've got something tough, it's like overtaking, you can put your foot down to safely overtaken through, but you don't always drive like that. So you can go up to about 80% power.
But you could go over it 2 or 3 times at a lesser power.
Yeah.
If you
Yeah.
wanted to go more, rather than go 90%, maybe 330.
Yes. The other thing that you've got down there is the number of passes. So if you say you've got some 12, 15mm material, rather than trying to cut through it in one pass, it might be easier to do 2 or 3 passes, and you can tell this to engrave once and then cut 2 or 3 times.
What happens if we get it wrong? You know, of these speed.
It doesn't. All that happens is that it doesn't do what you want it to do. So there's no danger, there's no problem. It's not going to, sides aren't going to fall off.
You put it in and it's too powerful and it's cut straight through it, doesn't
Yeah.
matter.
No, it doesn't.
It's rigid there.
You won't cut a hole in the bottom of the lake.
Something disappears.
Yeah, I know.
What
That's
we're
the
all-
obvious thing, yeah.
To get the best quality of cut, so that when we're cutting clear acrylic, we should have a nice smooth surface going around there, and it should be clear. And you know, to get that right, then we want to juggle this power and speed setting. I mean, it's like if you're using, have you got a wood turning lathe? Yeah, it's like if you're trying to, you know, work on the lathe. If you get it going too slow, it's always difficult. If you go too fast, you know, a small mistake and, you know, you can be off the mark. You just try and get a nice middle speed. And this is exactly the same. And on the wood lathe, the experience will tell you what you've got to do. And on this, the experience will. And we can, you know, preset on here. So you've got 32 colours, I think, this on this. Yeah, 32 different colours. And you've got 32 colours. So you have two basic operations. One is called line, which is where you're cutting. So that if I've got a letter O, it'll just do a line going around there, and that's line. The other one is fill, and fill, if I did the same circle, then it would go across and it would fill it in, it would engrave it. So your two operations are line is cutting, fill is to engrave. And again, you can have different colours there for different operations. Okay.
Go back to the colours, just the question he was asking.
That's on here, yeah?
Yeah.
And you pick the colour and then you can change the power and the time on that to suit, you know, it's adjusted. One colour doesn't mean anything, and even if I pick black and have
If
it
you wouldn't
say,
understand that, you wouldn't
then
really
you
want to
come on
change.
next time and
Everybody
you
else
can
is using
adjust
it, you want to keep a similar setting, wouldn't you?
sort of,
And
but
the
you'll
next
end up
person
with a
can
bit
use the
less.
same setting,
Yeah.
know what it is.
Yeah.
Okay. Right, once I've got my design phase done there, and I'm just going to put a letter into the centre. That will put put an A in the middle of there. Okay, so we've got a circle there with an A in the middle. So we're going to cut the circle and we're going to engrave the letter A. So at the moment, both of those are in black. So at the moment, if I go over to here and I double click on my black layer, this is where I can set it up. This is where I set up my speed and power. And again, you only do this once. So we're going to set the speed on this, it's 6 mil thick, so I'm going to do it at 8 millimeters per second. That's somebody's already put some preset settings in. And I'm going to do this at 40% power.
Really, that's just, you just takes, you know,
I'm just guessing.
6 or 8, 10 times, you just do it and just work the way whatever you want. Just keep changing it. There's no right or wrong.
No.
Everybody wants something different.
Okay. So I've got a setting there. I don't know if it'll cut all the way through. We'll find out. And then I can go to my letter, highlight that, and I'll go and do this as a red layer, and then the red layer will be to engrave it. And again, now I've got a second layer going over on this side. And here I'm going to do the speed at 200 millimeters per second. I'm going to do 30%. And in the mode, I change that to be. So there I've got a basic design done. So I've set up my circle, I've made it the size I want, 25mm. I've made it the layer black, and black I've told it is going to be line, and I've put the settings in there sufficient. I hope to cut it. Then I've picked up the letter A in the middle there, and I've changed that to a red, and I've said that I want that to be engraved, and I've set up the head is going to move quicker, and the power is going to be slightly less. Okay.
What does it cut first? Does it engrave the letter first before it cuts the circle?
Yes.
Always engrave before you cut.
Yeah.
Because otherwise it'll be loose.
Yeah.
That's right. And here, it will generally work in the order that it appears in the list. So, I've got my second one there, I can just move that up with the arrow there and set it to line. The software itself has got a certain amount of intelligence in there and optimization, and it will try and do that for you. Also, we've got the little television screen up here, and if you want to have a look before you start, then it will show you how it's going to engrave it. You can see by the shaded areas at the side there, that's where our overrun is. At the bottom there, it tells me that it's going to take me about 1 minute and 30 seconds to do that, and it tells me how far it's going to go and do everything else. I can then get it to run the simulation. It'll actually run it, and you can see the order that it's going to do everything before it actually gets down there and does it. But
I always, well, I think it's important to check the time of the project, because sometimes if I got the engraving wrong, say I wanted to do a line,
Oh, yeah.
and I accidentally put engrave, then when you check the time, if you know what you're doing, it's only going to take a minute, but sometimes engraving, you can come up and say 30 minutes, because it's doing
yes,
all the...
you can
so
see
it's really
there.
important to do the time.
Yeah.
And that proves that you've got what you want.
Absolutely right. Yeah, I find this very useful. Certainly if I'm doing a complex design, how long is it going to take? And I might find that I can juggle things round slightly and actually reduce the time.
No, but the thickness of the letter itself,
Yes, yeah,
the width of the letter.
yeah.
Doesn't matter, because this will take any font that you've got, so you can stretch and elongate the letters. So, and also you've got the normal, narrow and bold lettering. It will do any font that you've got on the computer. Because you're doing etching, it will just follow the standard procedure. But you can, you know, stretch and expand the letters going down there.
Wider or narrow.
Yeah. Think of this in a lot of ways like a printer. Wherever you put on there, the laser is going to do it. Okay, it's a printer with an attitude problem, but it's still basically just a printer at the end of the day. Okay, so I'm going to run this through on here, and I'm going to run this first time through, just so that we've got the lid open so you can actually see what's happening. Okay? Right, so down the bottom here, I've got pause, stop, start and send. Pause, just normal, if it's in operation it will stop it. Will pause the operation, stop will abort the operation, start is to start it up. Send is interesting. It will actually copy your design down to the controller. It'll ask you to give it a name and it will store it away in the controller. You have got about 128 meg of storage within the controller itself, so you can store a lot of files down in there. So if you've got something that you're doing a lot of, regularly do, The guys who use that a lot are the ones who do the number plates in cars. That they'll have, you know, a 60/40 or a 90/60 machine, and it will just do the letter A. And they juggle the letters around so they waste a least amount of material. So they'll just have a full sheet in there of A's, B's. So they're only ever going to have 36 files. All the letters, all the numbers. And then they just produce those out en masse. So they find that very useful. Most people, like yourselves, it's going to be, you know, a design that you're going to produce or that you're going to borrow from the internet or wherever and be able to run that through. So it's easier to run it off the computer itself. Next line going down is frame. So if I want to make sure, let me just come out of that one there. If I just want to make sure that my design there, that it's going to fit on the piece of material, I can just go down there and press frame, and then that will move the head round and it will give you an outline of the size that it's going to do. You have then got over there to save to an RD file. Now, if you come up here to file and do a save, it'll save your design. If you save to an RD file, it will save your design and all your power settings and everything else. Then you copy that down onto a memory stick, plug it in there, use the file option on this, load it up and away. So, you know, you can do this off and away from the main computer. And we have within our software pack on here got RD Works, which is 90% the same as Lightburn. That is free. You can put that onto as many different computers as you like and do your design in there. Save your files, just bring them in and do them in here. And the other one there is run an RD file. So somebody's brought a file in, and instead of plugging it in, you put it in there and just run it straight off the memory stick. Okay.
We were very quick about the running the test, the visual test.
Yeah.
I think that's important as well, because sometimes you might not know if you've got the right scale. So when you press that, it actually goes over the plastic or ply. It actually draws out, so you can see that you're not going over the hole, you're in the right place, and you're not wasting material.
Can I?
The ability to fine tune, when you did that close up there, the letter's quite low down, to centre the letter on the centre of the circle, to get that fine tuning
Yes.
before you actually print. Now look, it's going to cut a hole in the circle, but to control where it cuts that hole, rather than just randomly placing it visually, there'll be a degree of control.
Yes, very much so. The
When you,
Lightburn.
well, yes.
if you look up here,
You
if
look
I
at the
highlight,
television image, sorry.
oh, on the tip, yeah. If I highlight just the letter and I look up here, they'll tell me the centre point of the letter. If I just then click off that and highlight on the circle, it will tell me the centre point of that. If I want to get that letter dead in the middle, then I can just adjust those two centre points so they're both
So if you go to the television image,
Preview.
yeah,
which now you see, that black edge of, that will be the engraved portion.
yes,
And it's quite near the edge, the bottom edge of the circle,
that's right.
and it's quite far away at the top end. So to get that fine tuning just visually, I would want to move that up a wee touch,
Yeah,
so that
Find the whole grid, can't you?
yeah,
You can,
Yeah.
yeah. So you can do it by side or you can
just
do
the,
it.
the ability to do that's close up view.
You can't do it on this
You
stage.
can do it now.
No.
Okay, that's fine.
Because that's just, showing you a preview.
But you can zoom in and that.
When you zoom in and out,
Yeah.
Ah. All right. Yeah.
Sounds good.
Yeah, so
You
we'll do
want to
that.
have that check before you
Yeah,
press the
yeah, we'll just get it there. Right. Okay. A lot of this is going to sound, it's just going to go over the top. A lot of it's going to sound like gobbledygook as we go through. It is remarkably simple and straightforward. It is, you know, positioning the laser head there in relation to that, and then the difficult part then is going to designing. The hard part about this is thinking up the design and what you're going to do. And once you've got your presets in there, then you can just tag all the different bits that you want as different colours, and then it's off and away.
Can you import designs? Into
Yes.
there?
The import facility is fantastic.
So you can design on something else and just say,
Yeah. And you can import photographs, you can import, I mean, the list is like this of what you can do. Adobe Illustrator is a lovely one because Adobe Illustrator uses the same colour schemes, so then you can actually, in your design, just put the lines, the colours you want them, and then the design comes straight across. DXF, AutoCAD style files are brilliant cutting ones. You can do TIFF, bitmap, SVGs. There's the only one that it won't import is CorelDRAW, because nobody imports CorelDRAW. CorelDRAW put loads of gunk into their files so that you can't import them into anything else. But all you do then is that you go to CorelDRAW, you do your design, and you save it as an AI file, Adobe Illustrator, all part of the same group, and then that comes straight in. But CDR files, CorelDRAW files are rubbish. Okay.
Did you see rubbish?
Hmm?
Did you see rubbish?
Yeah. Because they put loads of junk in there, and it's just totally unnecessary. They put loads of headers in and copyright certificates and everything, which just stops anybody else from being able to look at their files and be able to read them. So CorelDRAW is sort of, it's ours, but just say and if all else fails, there's a marvellous free product out there called Inkscape, which will basically take in virtually anything and export it as virtually anything. Right. Let's see if the machine works. Okay. Right. So we've got the lid down. We've got our setup down here. We've positioned our material. We've got our width set. What else is it to do? To give it a go. Okay, so the first thing it's going to do is to do our engraving. Right, that's our engraving phase done.
So we're okay looking at this with the lid
Yeah.
up, aren't we? Yeah.
you'll know if you're not.
Hmm?
You'll know if you're not.
Just with one eye open.
Okay, that's not acrylic. I'm not sure 100% what it is, but it isn't acrylic.
Perfect, isn't
Perspex is
Macro.
acrylic.
it? Well,
I'd say
the
that's
first
some form of polycarbonate.
could well be.
So, is that some of the macro? I saw some macro ones. Is that, did we have that in here?
You want a piece?
That's the stuff
Yeah.
that's on the bus shelter.
I think,
Ah,
I think it's
polycarbonate.
macro
It's
one.
polycarbonate then.
Yeah.
Yeah.
Aye.
The only reason I'm telling that is because acrylic will give me a nice clean cut there. Polycarbonate, it's
Much harder.
what we actually produce the screens of up here. Ah, right.
That's a good example of placing the laser.
Yeah. Okay.
Yeah.
Yeah, can you?
Oh yeah, it's smaller
Yeah.
page.
Yeah,
Uh,
that's off 64.
yeah.
Okay, I'm going to do the same as we've just done, but I'll do it on this piece here. So again, because it's not where I want it, so I'm just moving that over there. Now this is thinner, so I just need to bring my bed slightly. Okay, once I've moved the head round, I again just press my origin button just to tell it that I've finished manoeuvring it round. Now, I've already got that design in the system because I've copied that from there down to here. So all I need to do this time is just press the start button because the design is already there. That's looking a lot better. We've got a bit of tissue cloth.
Yeah.
That'd be fine. Ah, right. Right, I've copied it across and I've copied it across. Same way.
There's no smoke coming off.
Do it 9 times. Okay, so
Yeah. Right.
I'll just do another one of those. That gives me a chance to a quick slurp of tea while that's going on. The advantage of drinking black tea in this job, apart from the fact that I prefer the taste, is it's as good cold as it is warm. Okay, I'll pass this one round. Now that one I haven't cleared the dust off. You can see where it's engraved, you've got the dust coming round and through onto that one.
When
Right. That's the same settings done in wood. It's just hung slightly on just that one little bit there. So we're using the same settings all the way through for the acrylic as we are for the wood. You'll find this quite often, that we give you 32 different settings, but you know, it's the thickness of the wood and cutting, the thickness of the material and cutting it that makes the difference. Also, just looking at this ply here, you can just feel it is slightly tacky when it comes off, which is probably indicating there is a resin-based adhesive in the middle there.
Is that maybe just a slight smoky deposit on the wood round about the... Is there a slight smoky deposit on the wood?
Yes.
Yeah.
My fingers are a bit.
Yeah. And you were saying you could leave,
Yeah.
if you put drafting tape over that?
That's right.
Yeah.
Now, that's a good example there, where it's the majority of that's gone through, but just in two little places there, there's probably something in the wood itself, which is just, you know, stopping it from going through. So I'm doing that at 8 and 40. So what I would probably do is just to edge that up to say 45 and just make sure that it went through.
As long as the laser lasts, is there a lifetime on it?
The tube itself is probably about 5,000 hours. So normally we'd say normal usage about 3 years. The tube itself is about £200 to replace. So if you break that down, it's going to cost you about £1.50 a week in operating costs.
Do you get a bit money back in the old one? The old tube?
No.
No.
But the good thing is that we don't charge you for disposal. You can't take it and dispose it in Norway because you can't with fluorescent tubes nowadays. So if I pass that round, then you can see the one that hasn't cut and the one that has. So, now, somebody did say that we got a design of the hut here.
It's on the...
Set up for the diode lasers.
Okay.
You want to see? See?
No. Right. Okay, so we've got a design there. Now, okay, so we've got that stupid change. Right. Have you got the one up there? Okay, so we've got that as a design which we've just imported to be able to produce that. I've just had a guess at a few settings on there. So I highlight it. I can see up here that it's 120 millimetres wide. Slightly larger than that. But if I wanted to alter the size of that, this is going to be, let's say I want to make this exactly 100 millimetres wide. I've got that highlighted. I can just go up there to the width as we did with the circle, close the padlock, and then just make that. Makes it 100 millimetres, shrinks it all down, and resets it all for you. Right, we'll do one of these on acrylic. We'll use your acrylic there for it. Just as
When you're setting the point of the laser start, on the program, you have to say bottom right, top right, left.
no, because any design that we put in picks up this job origin corner here, which
Yes.
is up in the top left-hand corner at the moment.
So the default is the top left.
Yeah, well, only because I've set it up for that.
That
It's
doesn't
not-
mean, so you can pick any default
Yes.
point, any start point.
Yeah.
on the
I
program.
can do it start from the middle. As I say, if I'm doing circular coasters, I always find it easier just to go a centre point and work out from the centre there. But anything like I tend to, top left tends to be the way my mind works, so I tend to work from that sort of basis. Okay. Right, I've probably missed something quite important within the design, but doesn't matter. We'll give it a go. We'll see what it's going to do. That's the whole point about it. I will stop that. So we've got to have to keep doing everything 9 times.
Switch.
Right. Sorry. Apart, somebody said.
If you are doing it 9 times, how does it work?
It just keeps repeating the same thing 9
Same
times.
footprints, not-
Yeah.
not-
So you can use this grid down here. So if I got this as a design, I liked it and I wanted to make 20 of them, I can just highlight it, put it to the grid and say do 5 across and 4 down. And also it gives me the chance then to say the gap in between. So if you're doing key rings, you're doing Christmas ornaments and that sort of thing, you want to do a whole lot of the same, then fine.
And officially, should you be closing the lid each time
Yes.
you're doing it with your hands in that danger zone there for
Yeah.
the purposes of the demo?
I think
Or
we
we will
should
ignore that.
I think we would have a rule that we cannot be operated with the lids open.
Yeah. It is part, it's just for doing this with everybody here. That,
I know.
but you cannot see, but between there and there, you have got the laser beam, and if you put your hand in between there, although you can't see it,
You'll feel it.
you will feel it. So, can't emphasise enough, apart from that, it helps the airflow. It keeps the fumes, keeps the extraction, helps the airflow and go through. It's only on this circumstance that we are making an exception.
Is there a safety cover if we switch it off, if you open the lid?
Yes. If you were to open the lid, and it gives you a message on the controller saying what you want to do. I can press escape, which means I'm going to abandon what I'm doing, you may look at it, you may look through the lid, and, is that quite right? So just lift it up. Oh yeah, no, that's fine, that's fine. So you put the lid back down, and then you have got enter escape. So it says machine protected, work paused. Continue, press enter, cancel job, press escape. So we want it to continue, so we press enter. If it was an engraving phase, it actually backs up about 10 millimeters, so it can get up to speed and power then, so that it makes the resumption seamless. I think I've totally made a mess of the settings on it. And instead of being a pagoda, we've ended up with a jigsaw puzzle. Right, that's what it's supposed to look like, that's what I managed to turn it into. So, yeah. So, it's just the fact that I juggled around with the settings, and where it should just be putting nice lines in there.
It's just the line across.
Yeah.
Yeah,
I've just cut it a bit too much. Okay. But it shows you that you can't go wrong. You might not get the effect that you want, but that's all. It may be that you've overcooked it and you've cut through where you should be putting a line. You may be undercooked it, so you got a score line when you wanted to cut down through. You look at it, you have a look and say, ah, right, it's there. Okay, it's that blue line there. So that's the one that I've got wrong. It's as simple as that.
Do you change the settings of lines all the time? You know, the colours. Do you use, for different materials? You always keep black for, say, cut or something like that.
They're just presets.
I mean, this is part of the building up your library of settings.
Yeah.
Is that you're engraving, the majority of the stuff that you're going to engrave will all be much of a muchness. The engraving for wood and for acrylic and for glass, for slate, are all going to be much of a muchness. The things that vary are the cutting. If you're a thicker material, a harder material, then you're going to need more power. So you'll end up doing a 3mm and 6mm acrylic, 3mm and 6mm ply, 3mm and 6mm MDF.
So where do you keep a note of that?
Anywhere you
if
want.
there's more than one person doing it, using it, like
Get yourself a printer sheet up there with your colours going down, or the order there, and right next to it 3mm ply.
Yeah.
But also, when you set up your layer over here, then you can give it a name there, and that name can be 3mm ply, 3mm acrylic, 6mm ply, 6mm acrylic.
Do you have a handout of the standard ranges for cutting and engraving materials?
There is a memory stick in there, and part of that is a calculator. It's something that we're in the process of developing, that you'll put in that you've got acrylic, you'll put in the thickness, you'll put in 50 watt, and it'll give you a suggested cutting speed. And if you increase the speed on there, it will increase the power and play around with that. It's probably not going to be guaranteed 100% right, but it should give you a good starting point. The maximum thickness that is how far the bed will drop down. So you could say do engraved boxes that were 70, 80 mil thick, 80 mil deep, and engrave the lid of the box. If you needed to go a bit further, you can just take the honeycomb bed out, put it down into there. So yeah, doing box lids. The maximum thickness of material you're going to cut is going to be about 12 mil, about ½ inch on a 50 watt.
12 mil in one cut.
Yeah.
So in theory 48 over 4 cuts if you had the range.
It does, that does work true. What tends to happen though is that after the first cut round, it tends to leave debris in the cut. So the next cut that comes round has got to get through the debris and the tube. So your first cut might say do 6 mil, your next cut might only do 5.
So as Rod said, the first cut's the easiest.
A wise lad, a wise lad.
Does the material have to be of even thickness? I'm thinking, for instance, raw slate.
No. Yes. I have, with one of these, done 50mm diameter Christmas baubles, the glass baubles, and I've got about a third of the way round. We did the one show last year and engraved a pumpkin. You know, we put a pumpkin in there and engraved round it. Your focal range, to get it right, is, you know, a reasonably narrow sort of band. But if you're going to engrave Christmas baubles, yeah.
No, I was thinking more, say a slate.
No, slate's fine.
If the laser has to be adjusted so that it's cutting the surface.
Because you're engraving, what's going to happen is that you've got the laser beam coming down to a point.
Yeah.
If you've got a depression in whatever you're doing, then the laser beam's going to go out. So in the depression, it's not going to be as crisp as it would be on the correct surface.
But it will do it.
But it will do it. And actually, there is a certain argument that if you're engraving materials like that, of bringing the laser out of focus, so that instead of it just doing nice parallel lines one on top of the other, if you put it slightly out of focus, it'll overlap and you'll get a smoother, but you won't get that real crisp edge to the lecture. So, yeah, it's a machine like any other, and it's part of the skill and part of the enjoyment in the operation is, I wonder if it'll do this. Give it a shot.
Got a bit of slate there.
Hmm?
I've got a bit of slate there.
Yeah, grab a bit of slate.
When the thinner plies that can...
Oh, thinner plies,
So
yeah.
you can put weights on as long as you're out with the range of the laser.
Yeah.
Whatever.
Yeah.
Yeah, well, there we go. Right, now we know we can't cut this. So,
That was off my roof.
Just say, £10 in the slate.
You're in the trials last night.
well, hang on, I'm going to delete that. Men's shed is in positive lights.
Yeah, where's Colin? Yes.
Okay, 200, that's what we were using for engraving the acrylic, so we use the same setting.
Does the engraving always require like an enclosed area of red lines, or?
Yes.
Yeah.
Yeah, if you've got an open circle and the operation is fill, it can't fill it, because, so it will come back. That's where the TV thing's quite useful as well. It'll come back, and you can see. And I think in Lightburn there is a little setting that will allow you to go to automatically enclose areas like that.
Right.
How about transferring a photograph, a portrait, head into a line drawing that you can engrave?
Doing photographs, the classic example I had was a friend of mine.
I was thinking of making posters of the family, pictures of
Yeah,
different outlines and characters.
yes you can. For a classic example was a friend of mine. She got a grey fluffy dog. The dog died. The only photograph she got of it was in a field of grass. So of course you turn it into a black and white image, and the only thing that you could distinguish on this were two black eyes peering out at you. And she said, oh no, look at that. If there is again on Memory Stick, there is an introduction on how to convert photographs into being able to engrave on wood. Wood tends to be about the better medium. The main requirements are that they've got clear definition, that they've got sharp lines within them. So churches, buildings, that sort of thing where you get nice edges, those work out fine. Or if you're taking photographs of people, that needs to be on a good contrast background. Okay. So if you are going to do photographs, it is, I'm afraid, more art than science. Yeah, our introduction there will tell you how to do it. One of the classic things that people do is to do all the conversion, because you've got to convert it into black and white and one bit and all that, and then they alter the size. You start off with the size that you want it to end up, and then do the alteration, and that tends to, save a lot of the problem. But it isn't easy.
You draw the lines in it's missing. You can draw lines in it's missing, then if you can help it.
Yeah, you can do that sort of thing.
From the drawing.
And you can get it to outline it so they'll cut it out, but yeah, it's a good word. It is tricky. I have varied success with it, mainly because I don't do it very much, and I know people who do a lot of photographs get some stunning quality out of it.
There are some software sort of things on your computer. You can take a photograph and convert it into like a light drawing.
Yeah.
And that I think that would be the way to go. Something, depends on your software.
Right, the free software that's not developed to test.
Lightburn is probably the best of the non-specialist softwares for doing photographs. There are a couple of specialist programs out there, because it is such a tricky subject. There are a couple of people who produce specialist software for taking photographs and converting them to laser. But at the moment, the software is about £300 or £400.
I just tried to see one for portraits.
Yeah, we're just waiting for the price to come down.
So, curious to see, would it work in this tile? Like,
What my answer to that's going to be?
I said no.
Of course it is. Let's see what it does. Right, again, because that's a lot thicker, we've got a ceramic tile.
Yeah.
That only comes up so high, it wouldn't press that too hard then, will it? If you press it too hard for coming up. To adjust the focal length. When it comes up, you can't just keep going.
No, it
Stop.
shouldn't. It should stop before it hits the nozzle.
Right.
But yeah, it moves very slowly. I keep complaining to the the manufacturers in China about this, and keep saying, look, can't we get it to move faster? They say, it moves slowly, but it's very precise. I'm working on that. Okay, let's see what happens this time. Certainly what I've seen with tiles is that people have, say, got black tiles, put masking tape onto it, engraved it, which is taken the glaze and that on, and then painted inside the masking tape, and then peeled the masking tape on.
I've got a stack of these on the out in my shed, so.
Does it always have to be controlled from the PC? Can you control it from...
Sorry?
Can you do some of the controls from the control panel?
You can do, but the only real one that I tend to use is the repeat, the start pause. I tend to, there's a lot of functionality there which is built from, previous to allow these things to be backwardly compatible. But it's so easy and simple, straight from here, that,
So when you're doing your pace, you do the pace, but
yeah,
you can put that and then run across the machine. That's it.
keep that somewhere.
Yeah.
So the glass would turn up something,
Yeah.
similar, like on glass, yeah.
Yeah, glass and clear acrylic. I always flip the image, which you've got the facilities up here to flip horizontally and vertically, and do it on the back of the glass or do it onto the back of the acrylic.
Right.
So you get a nice smooth finish at the front. If you do mirrors come out stunningly good, but always put the mirror in with the silvered part, the back face up. Don't put it in so that you're firing a laser beam down onto the mirror. It will tend to, not bounce back up. But what you're doing is that you're getting the front of the mirror engraved rather than the reflection part of it at the back. There you go. That probably needs a bit more but
Yeah.
so,
Yeah. A bit more power or
Yeah.
reduction in speed or whatever, yeah.
Is that the same setting as that?
Yeah.
Yeah.
That, for the engraving, that's the same setting as we did for there, for that. I've just kept the same setting all the way going along. Yes. Yeah. If I got men's shed there, all I need to do is go up to there. That's it, reversed. Easy done, just off and the way down, do it on the back of the mirror.
Yeah.
Or if I'm using glass, on the back of the glass. Slate coasters for local pubs and restaurants are a nice little earner. The white lion or whatever it is on the side there.
Yeah. I'm just looking at a big mirror there.
Not Scottish slate.
You can. Most of the slate that we get in Wales now is Indian.
Most of the slate is
Indian. Comes in from India.
Yeah.
There's so few slate quarries working up round Blaenfestiniog and up round that area.
None in Scotland anymore, I don't think.
No, but I've got some guys in Scotland who do pet tombstones
Yeah.
in granite, and they engrave those and just set them up on the mantelpiece or wherever.
The Scottish
that-
slate's too thick, too rough.
That would be Ballyhooly slate, it's 100, well, more than 110
Yeah.
years old, but it's, but it's since it was made, Yeah.
Yes, I've come down the scree slope at the back of Ballyhoolish, coming back down there, and that's
Yeah, well, there's whole areas of waste and offcuts and mountains of it.
It's a good horseshoe, that, isn't it?
Sorry?
It's a good horseshoe,
Yeah,
Ballyhoolish horseshoe.
yeah.
Just never made enough money to go and stop at the hotel.
Is your data stick protected from being wiped out accidentally?
I'm
The
sorry.
data stick is protected, it can be wiped accidentally.
What, the software?
Yeah.
No.
No, that, USB
Memory
stick.
stick.
Oh, no, 'cause it's not a surface code, you're actually going into it, so.
I thought you said there was stuff on the USB stick.
Oh, I see what you mean. I'm totally sorry, I'm thinking of the engraving on there. The memory sticks aren't protected, so first
Somebody,
thing,
because we get different people using them, and somebody might wipe something.
yeah, so copy it up, make a copy of it, you know, do your normal security.
So copyright protected.
Yeah, no, they're not copy protected at all.
You want to keep them after somewhere, make a copy. If somebody's like, okay, oops, right there. Aye. And that means you keep the original somewhere safe, and make a copy. So when somebody waits, you can get it back up.
Okay, that's your memory stick, and which we just engraved with Red Dragon laser on. Right, maintenance. If you're using the machine, it does need cleaning, it does need looking after, but the maintenance is quite straightforward. That is your main maintenance tool, cotton buds. So we give you a few of these free. We tend to use the ones with the bamboo in the middle rather than the hollow, don't injure the babies here, cardboard ones, because those tend just to fall apart. All you need to do is there's curing there for putting keys and stuff on. So all you need to do is just give a spray onto one end of there. And I'd probably suggest initially you do this at the end of each week, as a sort of once a week. To be honest, probably once a month's going to be more than adequate, but just start off, give it a once a week. And all you do is that you've got this mirror here, and you've got this mirror here. So for that, you can just go in there, clean the mirror off, put the dry end in, and just dry it. Same with the mirror there, clean it, dry it off. About once a month or so, have a look at the lens, just in there. That just unscrews, drops down. You've got a zinc xenilium lens in there. And again, just give that a wipe over and make sure it's clean. If you find all over the bed that you're needing just a little bit more power than you used to, that you need to drop the speed a little, it needs a little bit more effort all the way over, then that's because the mirrors are going a bit mucky. So that's your cleaning. If you find everything's hunky-dory in this top left-hand corner, but down in this bottom right you need a bit more power, that means that the mirror alignment has gone out slightly. So you point in the laser beam, if it just drifts slightly, the further you are away, the more there's going to be out. So when the laser's down in this corner, the distance from that mirror to that mirror is at its maximum, and the distance from there to the back is at its maximum. Its mirror alignment is very, very easy and simple. I'll give you a reel of what is actually quite naff double-sided tape, but it's brilliant for this because if you put masking tape on, masking tape just goes up in a cloud of dust. So all you do, break a little bit off, just put it over the hole there, and then just do pulse. Pulse is a quick burst of the laser beam. And there you can see that that's hit spot on and in the middle.
Right.
If that was off and away and up to one side, so if that's the hole that it's going through, the moment it's going there. If it's off up here, then that means that all the energy is being absorbed by the metal there and it's not going through and down onto the material. So you have got 6 screws on the top of each of the mirrors. The silver screws, you can take those out, those are spring loaded, that'll allow you to take the mirror away and have a good clean and good circle there. Put it back. The brass screws are your adjustment ones. They've got lock-in nuts on the end, and as part of your kit, so there's a small spanner there which will undo the lock-in nuts, and you've got the Allen keys there for undoing the silver nuts. The only trick, the only secret, the only way to do alignment is that you start with this mirror here, the back mirror won't move. Start with this mirror here. Put your tape over this part just here. Have a look at it and do small movements, and if we go back to where I was saying with this, if the laser beam's coming up here instead of going through the middle, then adjust the screw there just to bring it down, get it halfway, fine, lock it off. Then do the screw to move it across, bring it into the centre, check it, lock it off. Small movements. I've gone in and I've had to put in an A4 sheet of card to try and find where the laser is hitting, because somebody's undone all the screws and everything else. It's not going to be far away, so you just want each one at small movements and small fine adjustments, and there is no secret. And totally realigning this should take from scratch about 10 minutes. Just checking should take 5. So just put your red tape over the end. You can see where it's hitting, and as long as that's in the middle, and then just at the finish, just put a little bit over the bottom of the nozzle there, and again do your pulse. And then you can see the beam coming out to the bottom of the nozzle, and it's in the bottom of the nozzle.
The adjustment for the bottom one, no.
The adjustment for the bottom is there. The adjustment for going across is this one here. It is simple, it is straightforward, and you will have an immense amount of fun. The difficult part is thinking up all the ideas on what you're going to do with it.
What about cleaning the bed? Because if you're burning it, if you don't apply it, it's smoky and dirty.
Yeah, good point. The bed itself, isn't fixed, comes out. You can see a little bit of mark in there just where we've been doing odd bits and pieces. The main thing with the bed is to ensure that the honeycombs don't get filled up with gunge. If they do, Mr. Muscle oven cleaner, the stuff that comes with a nice placky bag. Dishwasher, yeah. I prefer the Mr. Muscle. I bung it in the bag, I put it in the Mr. Muscle, give you a swirl round, give you half an hour, wash it over, give it a bit of a go with the hairdryer. It's not got a lot of other use, and yeah, that's it. The only thing with Mr. Muscle, it does take the paint off the side as well, but it does cut through and gets rid of the stuff that builds up within there. But that's a once a year, once every 2 year sort of operation, no more than that.
The laser can't cut through that, doesn't cut metal, so
No.
cuts over the tank.
And if all else fails, give us a bell and we can always supply you with a new honeycomb.
Did we only get the one variant, or only one style?
You can put slats in here, which are horizontal lines that go up to a fine point. Those are very good for doing a lot of cutting.
This one, you know.
It's all right, you get the air assist, the air coming out of there. And it whistles down into the honeycomb, which annoys you to death. Yeah, slats are very good for cutting. The honeycomb is the best all-purpose bed. So, every now and again, clean any bits and pieces out that drop through. So just lift the honeycomb out, nozzle of the vacuum cleaner, just suck out the bits and pieces.
The other important thing is
The ability to keep it clean of, sawdust from the workshop or just general air dust, the top casings, is that just a cleaning a hoover?
That's fine, but the one thing to be sure about is that the water supply doesn't get contaminated. If you've got a load of sawdust in the water supply, then that's going to go through the ductways and there's a possibility that you'll get a build-up. Probably the easiest thing to do is to get the lid there and cut 2 10mm holes in it and then put the pipes through there and just seal that off. So, end of the day when you're finished, you can either just turn it off at the mains, turn it off there with the emergency stop switch, to turn it back on, just go around there, or you've got the normal power switch at the back, just around the corner there.
You need the key as well.
The key,
laser.
that just comes away, and even though everything's turned on, then nothing will work there.
There's one key.
2.
The pump still works. It's good.
Oh yeah, pump still works, and if I went ahead and did my design here and start, put the lid down. It'll try and do that, everything will go around and work, but there's no power coming out of the laser. Because we turn the power off to the laser supply itself.
The other minor thing I was going to say, it's important to put the laser away from your project when you're finished, you're lifting stuff out.
Yes.
Because that, quite often you forget that, you've got to lift something out. Hit the laser, you always move it to the back right.
Yeah, there's nothing worse than having produced a really good piece of work and then somebody presses the start button and it starts going over the top of it again and makes them look good.
How do you put it to the rest? Just at the back? Is there a button for it?
3 arrows.
You've got the arrows up there, so I'll just press stop on that so it doesn't carry on doing. It rests when we turn it off. It just stops wherever it is. Then when you turn it on, it goes back up into this top right-hand corner, and that's where the switches are, just to calibrate it and start it off from. But then the head will go back. So if I do a reset there, the head will go back over into that top left-hand corner. And it'll come back to the last place I pressed origin. And it'll come back there. So If I move that right down the front, press origin, do a reset again. If I've been mucking about or, you know, I tend to like to do a reset occasionally just to get it back calibrated. And it comes back to where we set it up and did our origin. So your origin is not top left, top right or anything like that. It's wherever you've sort of said to start from. And you have got also your job origin down there, which is just in relation to the design, where am I going to start from?
It's at the front, your origin's near the front there, and you want to lift something out, how do you move it to the back, left
Oh,
corner?
right. You've got 4 arrow keys there, so that moves it to the back.
Yeah, there's no
Left,
piece
right.
anywhere,
And then once you're, again, moved it round, if you're happy with where it is, press origin, beep, it'll start from there. That's then when you put your piece of material in and work it from there. Okay, chaps.
Duncan had a question. How do you keep the laser sharp for cutting?
A little carborundum stone, just get it running, and you know, just put an edge onto it every now and again.
Right.
So what's this software that you can run on any computer?
That again is on there, and it's RD Works. Lightburn and RD Works both started off as an old product called LaserCut. And LaserCut was one of these open source softwares, so Lightburn took it and made it available for a wide range of different controllers. Ruida, who manufactured the controllers, and probably 80 or 90% of the CO2 lasers in the world are Ruida controllers. They made it so it only works on their software, on their controller. So you can put it onto as many computers as you like, because it only works with their controller, so they're quite happy. But if you look at the screen, they're 90% the same. RD Works, for us, is very good. It allows us to get into the controller and we can do a lot of in-background work. Lightburn, for you, is very good. It's got a lot of facilities and it's more user-friendly. Lightburn is always talking to the controller, which is why you can do the frame going down there. It's always there and linked up to it. RD Works, you can't do a frame because RD Works only talks to the controller when it's in operation. So there are things like that which, you know, are nice differences for you. For us, our benefit is that we can go and tinker and recalibrate, and there's lots of bits and pieces we can do in the background. They're all hidden away from the normal user, and we put passwords on them, but they're Lightburn you've got to pay for, but you get the benefit out of it. Actually, doing imports and SVGs, it does give a better effect on some of the import files that you get in there.
I think that you could prepare your files on RD Works at home, bring them in, import them into Lightburn, do a final tweak, and file it that way.
Yes, yeah. Well, if you're going to do them at home, then same as just on the memory stick, put the memory stick in there, use the file and import.
But did you say if it gives slightly better results on some of the things, then put the files into Lightburn and file it up that way?
Yeah, that tends to be from the raw, so from the SVG. To use the SVG on RD Works, you'd need to import it anyway.
Right.
So you're better off just importing it straight into there.
You have a laptop.
Sorry?
what with an Apple computer?
On an Apple?
Yeah.
Apple, you can, Lightburn will work on an Apple, RDWorks won't. Yeah, there is a Mac version coming out, but it's not there yet. Okay, you have got a sort of Facebook page which has got hints, tips. We don't monitor it, it's for you to talk to other people, and I think there's 600, 700, 800 people on there at the moment. It's a closed group, and so, you know, how do I do this? What sort of settings can do that? Do you know where I can get that sort of question? And also it's a nice place to go, hey, look where I've done. Okay, right, there's your 4040 operations manual. It's on the memory stick as well, but I still like giving out paper copies. The girls have talked me out of it now, so in future we'll just do. They got me into the 20th century, let alone the 21st. That's the controller, that's all the hints, tips, tricks, and technical details for the controller, and that's your RDWorks operations manual.
Is the controller manual on the stick as well?
Yes. All the paperwork in there. It's just I actually like, yeah. If I'm driving along in the van, I go, where am I going? It's very difficult to get it off the stick, or I can sort of go, ah, right. Yeah, King George V Park, yeah, that's fine. I know where I'm going.
Just that we can make the PDFs available to members as they require them much easier than photocopying.
Yeah, they're all on there as PDFs. You have got those which are 4 legs that just go into the corners if you want to raise it up. To be honest, I think that the support bars that you've got under there give you enough airflow and enough clearance.
Okay. I asked a question for you, Duncan. Yeah, I asked the question.
I'm not going to start again.
That's why I've recorded it on this.
Oh, GoPro. My son's nicked mine. If that's still reporting, I still want it back.